We'll work on script 2A, which covers reducers. Reducers are the counterpart of map, which are useful in computing statistics. Let's learn a little bit of background on reducers. If you've done programming before, map is intuitive. Wherever you think of for loop, you replace it with map, and you learn the syntax and it's fine. Reduce is much difficult to comprehend because if you've done any scripting like in Python or R, you have never used reduce. In most of the programming, you never encountered this concept. So it's a very alien concept for most people. This is a concept that comes from big data processing. So if you've done big data processing using Hadoop or something, you would have run MapReduce. And since we are also doing big data processing using Earth Engine, we need to learn about reducers. The good thing about reducers is you don't have to write a function. Earth Engine comes with a bunch of functions that are built in, which you can use for the reducers. And these functions are mostly taking form of all the statistical functions. Similar to map, you can run reducers on all the objects that contain multiple things. So if you have a list of things, you can reduce this. If you have an image collection, you can apply a reducer and so on. Similar to map, you can use this function called reduce, give a reducer function, and it will be run to compute some statistics. Let's learn visually. You have an image collection. So here you can see there's a stack of images, and you want to apply a reducer here. When you apply a reducer on an image collection, the reducer is done on every pixel of every image. So here you can see visually that you have this pixel and you say reduce this image collection. The reducer, whatever reducer you've chosen, will be run on all pixels of each image, and the value of the output image would be that pixel. The reducers are, you can do sum, mean, median, and so on. This seems very familiar, right? Have we done this before so far? Looking back at module 1, we have created a composite, right? We have created a median composite. When we did the median composite, that was actually running a reducer on an image collection. So reducers are useful for creating composites where a statistical function is applied on every pixel of every image in the stack, and you get one image. Right, so we learned the actual full syntax of the reducer today. Median is a shorthand syntax. We'll actually learn the full syntax, so you can apply all kinds of reducers to it. You can also run reducer on a single image. Let's say you have an image of temperature, and you have a polygon, and you want to compute the statistics of all the pixels that fall within the polygon. So you can run reducer on an image, and that creates a number. So you have temperature pixels, you have a polygon, and you say reduce region with the mean reducer. You'll get the average temperature within the polygon, right? So this reducer is used to compute, say, averages in regions or computing area. Okay, we'll learn about how this function works as well. In Earth Engine, almost all type of image processing is implemented as reducers. So if you are trying to think, oh, I want to do something, which I've done in my other software, I've done this in my remote sensing software, how do I do this in Earth Engine? Look under the reducer section. You'll find reducers like this. Remember, we did kernel processing. If you want to apply some kernel processing, they are implemented as reduced neighborhood function in Earth Engine, because you're taking a pixel, looking at the neighborhood, reducing them down to a statistical measure. Zonal stats. I have a bunch of polygons in my shapefile. I want statistic of each polygon. I have a shapefile of all the districts in my region. I want the average NDVI for all of that. Well, you run reduce regions, plural, and you'll get the statistics. I have a shapefile. I have a column. I want the sum of the columns in my feature collection. You can do reduce column. Raster to vector, we've already done this. Reduce to vectors. Vector to raster, reduce to image. I want to run linear regression, linear fit, linear regression, and so on. We'll also do trend analysis in this module. That's also, Pearson's correlation, sense law. All those are reducers. So all of the stuff that you are looking for implementing with your image processing and statistical analysis, those are implemented as reducers. Let's look at the code, and that will help you understand how to run those reducers. So we'll start with our list that we've been using. I want to have the list of numbers from 1 to 10. Let's print this. We have a list of numbers from 1 to 10. We want to compute the mean of all numbers from 1 to 10. What's the average of all these numbers? Right. So to do this, we can do something like this. MyList.reduce. This is the function you'll run on any object that supports reducers, and you have to find a function. Let's go and find a function that can compute the average of all the numbers from 1 to 10. We'll go to docs, and we look under ee.reducer. And you can see these are all the built-in reducers that you can use with the reduce function. You have e-reducer count, e-reducer first, e-reducer last, and you have this reducer here, e-reducer mean, that computes the average. So we can run this. You can see we got the answer that the average of all the numbers from 1 to 10 is 5.5. Next, we want to know the minimum and maximum value from all the numbers in the list. So what reducer would I use? You can use the reducer min, reducer max, or there is another reducer. It creates a reducer that computes the min and max of its input. So we can just do this, reducer min max. So you can see I've got two values as the output, min and max. Okay, so we have the min max here, we applied on list. Let's do something more useful where we can data. So we have, say, a polygon, and we have our collection, and we'll apply some filter. So let's say I have this filtered variable. So I have this image collection with 90 images that I found. So I have some polygon. Over the polygon, we have some images that we filtered down from the Sentinel-2 collection, and we have this 90 images. We want to create a median composite. Let's see how I want to create the composite. So far, I've taught you this syntax, right? We've done dot median. All of you know how to do this. Once you run this, you get an image per pixel median value. Now this one, this dot median is a shorthand for running the median reducer. So we can do this instead. We can say filtered dot reduce reducer median. Both the statements in line 26 and 27 are exactly the same. They do the same thing. This one is a shorthand for this larger syntax because you are doing this so often. The Earth Engine API provides you with a helper function that runs this reducer. So internally, this is what is running. Now, which one to use? Well, feel free to use any of them, but I want you to get familiar with this syntax because the shorthand is available only for like 8 or 10 reducers, which are most commonly used. Okay, dot sum, dot mean, dot median. But let's say if I want to run a Pearson's correlation, well, there is no dot Pearson's correlation. You have to say dot reduce, e-reducer Pearson's correlation. There are over 200 reducers that are available here. So if you want to run this function, interval mean, well, you have to say dot reduce, e-reducer interval mean. So the full syntax allows you to use all the reducers that are available in Earth Engine. The shorthand is available for the most commonly used, but they are exactly the same. That also brings me to the point of not using all the AI assistants for Earth Engine coding because the AI assistants yet are not very good at Earth Engine API. There are not many examples in the public domain. So if you ask ChatGPT, can you explain me the difference between these two? It will spit out some very convincing nonsense, which will mislead you. So make sure you're being careful when using ChatGPT for doing coding. Once you learn the API, where ChatGPT works well is whenever there are some edge cases where I really want to use some JavaScript. So I'll ask ChatGPT to code up some JavaScript that I can use here. But again, nothing for Earth Engine API yet. Even Bard is not very good at that. Okay, so we can reduce an image collection and we get an image. We can also reduce an image to compute statistics of all the pixels. So let me bring a single image. So here I'm loading a single image, single Sentinel-2 image on the map. You can see this is a Sentinel-2 image for this region. And I have this red polygon, which is the farm that I'm interested in here. So I have this geometry, which is this representing this particular farm polygon, and I have the Sentinel-2 image. And I want to compute some statistics. You can see that this farm contains many, many pixels. So I have many pixels of Sentinel-2 image within this particular farm. I want to compute some statistics. So let's see how we can use the reducer for that. So I have the Sentinel-2 image. I want to compute the statistics. We take the image and we use this function for reduce region. So reduce region is a function that runs on images and allows you to compute statistics for a given region. Control space to autocomplete. It's asking us what reducer we want to use. Let's say I want to compute the average value of each band of this image. So we'll say I want E reducer mean. Geometry. What's the region that you want to run your reduction? So geometry. Scale. What's the resolution that you want your statistics? 10-meter resolution. I will skip all the parameters. Remember that this image, let me just first print the image. This image has multiple bands. So I have the Sentinel-2 image, which has got 16 bands. And when I say reduce region, I'm going to get the statistic for each band. So I'm going to get average value of band 1 within this region, average value of band 2 in this region, and so on. Let's print the stats. And now you can see we have the average value of band 1 was 1232 within this particular region, and so on. Sometimes it's useful to say how many pixels are there in this particular polygon. Can anybody tell me how would I change this to count the number of pixels that are falling within this polygon from the image? The correct answer is we change the reducer to be a count reducer. And it's going to count, give me a count of pixels from all the pixels with that. You can see there are 835 pixels within that particular farm. So what if I have 100 images and I want to count, I want statistics of every image in that collection? Well, you write a function that does this for one image and then map that function on the collection. And then you get statistics of every image. There's a question on what we want to count the pixels meeting a certain criteria. How do we do this? So let's say I want to find the average value of all pixels with NDWI greater than 0, something like that. So what you do is you create an image where you say mask everything that is NDWI less than 0. So you mask those pixels and then compute statistics. That means you are now looking at pixels about certain things. There's a question on how do we practice the Earth Engine syntax? Is there a website platform? Well, it's the Earth Engine documentation. If you go here in the user guide, this has got all the examples that teach you how to use the Earth Engine API. One particular reference that I want to point you to is in the user guide. There is a tutorial here, API tutorial, Introduction to JavaScript for Earth Engine. And this teaches you how to use the Earth Engine API to do some computation. In particular, this article says this is the Earth Engine style of coding. And the technical term for this style is called functional programming. When you've written code in Python or R, that's called imperative programming. Essentially, you are executing statement step by step, and it runs this. Versus here, you need to write functions to do processing, and that's a functional programming style. So if you are ever stuck on a problem and say, I don't know how to implement this in Earth Engine style, you can search saying that how to implement this in a functional programming style, and you'll get some idea of how to implement this. This shows some examples. When you want to have a for loop, how do you write a for loop? Well, you replace it with map. When you have to, how do I avoid do if and else condition, right? So if I say I want to implement some if else, what's the functional way of doing things? And that is shown here. What's the correct way to do this? I'm going to share the link in the chat, and we'll also add it to the notes.